All right, so yesterday we looked at some terminologies and different ways to gather samples from a population, and today we're going to look at errors in statistics, including margin of error and bias. So in statistical studies process, after we collect a research question, we begin by collecting our data, and then we organize, summarize, analyze it, and then finally we draw conclusions or references. So one of the things that we need to kind of consider as we're going through this process is the potential error or the inaccuracy of our data. So what's called margin of error? Margin of error is a statistic that estimates the amount of sampling error in the results of a statistical study. That does not mean that somebody made a mistake and messed up their research. These techniques, when used correctly, can be trusted to give results that are accurate within a certain range. So a margin of error is like to say that we are confident that that the average heights of male are within this height by plus or minus 2% type of thing. So the reason why margin of errors occur is because if you think about like if you're trying to define, I'm just going to use this as an example again, the average height of males over the age of 18, let's just say in the entire world. That's a lot of people, and so depending on what your sampling size is, because that's not possible, it's not realistic, not practical to measure the heights of every single male over the age of 18 in the entire world. So you take a sample, depending on the size of the sample, for instance, can determine your margin of error. If you go and you took the average heights of everybody or the guys sitting at your table, compared to the guys sitting in the class, compared to all the boys in the entire school, compared to all the men, like that, you'll get closer and closer to an actual average height there. So we end up getting this margin of error, and we're going to take a look at some examples on how this is used in the real world as well. So we're not going to actually calculate the margin of error, but we'll need to be able to interpret kind of what that means. Okay, so I just kind of went over this type of an example. So why do we have margin of error, and how can this range of error be reduced? So the margin of error is in a range, saying you're confident that the average heights of males is somewhere between this and this, based off of this margin of error. I'm not going to go into this deal again because I just went over that. But one way that we can reduce the margin of error is by increasing the sample size. So for instance, if we're using that average height of men over the age of 18, rather than doing like just the guys over 18 in my class, like do the guys over 18 in the entire school, or collect data over, go to the mall and collect data on 1,000 different guys that you think are over the age of 18, and just increase that sample size, and that can reduce your margin of error. So here's an example to kind of consider that I didn't know until I started teaching this class, but nutrition facts are FDA approved, but they can be misleading due to the law allowing a margin of error up to 20%. So what does this mean exactly? If a nutrition fact says that a food contains 300 calories in it, it may actually contain anywhere from 240 to 360 calories due to the margin of error of 20%. How am I getting these figures, by the way? Well, if I'm told that it is 300 calories and I have a margin of error of 20%, remember, margin of error is a range from like the smallest to the largest type of thing. So if I do 300 times 0.2 and 300, if I do 300 times 0.2, that will give me 20% of 300. So that's just 60. So my margin of error, how I'm coming up with those, is I take my 300 calories and I do plus or minus that margin of error. So 300 minus 60 would be 240, and 300 plus 60 would be 360. So that's where these figures are coming from. So once again, if a food label contains 300 calories, it may actually contain less or more based off of this margin of error of 20%. This means that the calories listed are not exact and represent an average within a range that should be plus or minus that average. All right, so here we have an example involving political stuff based on a survey of 1,500 U.S. voters. 53% of voters prefer Smith to Jones with a margin of error of 3%. How would you describe the number of voters who prefer Smith according to this survey? Okay, well, first of all, 1,500 people took this survey. We're given that 53% of voters prefer Smith to Jones. But there's a margin of error of plus or minus 3%. So what we need to consider now is that I have 53% with a margin of error of 3%. So I need to find out my high and my low here. So 53% plus 3% would be 56%. And then 53% minus my margin of error of 3% would be 50%. Since I'm asking for the number of voters who prefer Smith according to this survey, I'm not asking for percent. I need to find 56% of 1,500 and 50% of 1,500, and that's going to give me my range of voters that prefer Smith to Jones. So, for instance, if I have 1,500 times 0.56, that's going to give me 840. And if I have 1,500 and I'm trying to find half of that, that's going to give me 750. So my those out of the 1,500 that preferred Smith to Jones would be somewhere between 750 and 840. I can say preferred Smith over Jones because we have a margin of error of 3%. And how can we conduct this survey to reduce the margin of error? Well, we can increase the sample size. And instead of 1,500, maybe we do 5,000. And see if we can reduce that margin of error, or 15,000, whatever is reasonable. If 53% of voters are in favor of a school bond with a margin of error of 5%, can we confidently say a majority of voters are in favor of the school bond? Well, let's find out. So first thing I want to look at is what I'm given. I'm given 53% of voters are in favor, but I'm also given there's a margin of error of 5%. So I need to consider both above and below. So if this would be my range, 47 to 58. And we're asked, can we confidently say a majority of voters are in favor of the school bond? Well, a majority of the voters would be anything over 50%, and part of my margin of error dips below 50%, so I cannot make that claim to say that. Even though that I may be spread more, I'm closer to 50 on the bottom end, that does not matter. Like, this is a margin of error, and we have, in context of this particular question, since I have a percent in my margin of error that falls below that halfway mark, I would not confidently say the majority of the voters are in favor of the school bond. Okay, another source of error in statistical studies is called bias. And bias is the tendency of a statistic to over or underestimate a parameter. So just like with sampling, we have different types of samplings. We have also different type of bias. The first one we're going to look at is called undercoverage bias or exclusion, and it occurs when part of the population is excluded from the sampling process. So here's an example of what undercoverage bias is. So suppose you want to estimate the size of a moose population in a national park, but there's some areas that are maybe closed off or blocked off, or it's a super long hike or something like that. So you collect data and provide an estimate for the entire park, including the ones that you didn't actually access. That would be considered undercoverage bias. You're excluding part of the population with that. Then we also have what's called non-response bias, and that's when an individual chosen for the sampling are unwilling or unable to participate in a survey. So if a questionnaire respondent refuses to provide certain information like race, gender, income, age, etc., that would be considered a non-response bias. Then you have a self-selection bias. This is a voluntary response, and it occurs when individuals select themselves or volunteer for the sample. So, like call-in radio shows or online polls that are controversial, or they have a certain agenda that can lead to a sample to overrepresent individuals with strong opinions. If you listen to the radio, you can hear people call in all the time that they want their opinion heard. They have a strong viewpoint on this. That would be self-selection. Response bias occurs when respondents are influenced by poorly worded survey questions or by the behavior of the interviewer. We're going to look at a couple of examples about this here in just a second beyond this. So response bias can occur because respondents may lie when presented with questions of a personal nature or questions about illegal or questionable activity. Either way, many of these biases can be a result of convenient sampling in which individuals are sampled because they are easily accessible, which we've already talked about convenient sampling. So going back to the response bias based off of poorly worded questions, here's an example. So suppose you have two surveys that ask Catholics whether birth control should be made available to unmarried women. And the first survey involved in-person interviews, and 44% of the respondents answered yes. And the second survey was conducted by mail and telephone, and 75% of the respondents answered yes. So, which of the two surveys would you think would be most accurate, and why? Well, if you're thinking about something that is like this instance, you have Catholics and birth control and unmarried women, their morals are going to be a little bit different, and they may feel one way, but to your face, if you're interviewed, to your face, they may not be as honest with you. But they have really not a whole lot to hide if they're doing something by telephone or by mail. So we would say, sorry, I ran out of space. So the second survey here would be more accurate, and why? Because people are more likely to lie in person since confidentiality is less ensured in in-person interviews. Okay, here's another example involving something similar. So suppose you write two versions of a question for a poll. You ask people whether the government is spending too much on assistance to the poor, or you ask people whether the government is spending too much on welfare. Which of the two wordings do you think will produce a higher percent of those saying yes? In other words, the government is spending too much money on these things. They both mean the same thing to an extent. Like, they both mean the same thing. But which one is worded better to yield proper results? Well, if you think about this, welfare has a negative connotation to it. You hear this word when you hear like political debates and certain issues, like that has a negative connotation to it. So I would say welfare has a negative connotation of consuming taxpayer dollars. So part B, I think, would have a better, higher percent of those saying yes. Yes, the government is spending too much on welfare. To say that they're spending too much on assisting the poor makes you sound like a jerk. Even though they really mean the same thing. All right, now we're going to look at different types of bias, see if we can determine what they are. So drinking and driving is not considered a serious problem in Mathville, is the survey result. So somebody did a survey, they collected this data, they said drinking and driving is not considered a serious problem. Their method of survey: a researcher waited outside various randomly selected bars, and then they asked every third patron who exited if he or she felt drinking and driving was a serious problem. This would be considered undercoverage bias, because people who are strongly against drinking and driving or alcohol would probably not be in a bar and therefore be excluded from this survey. So once again, I'm not going to write this down, but you should. For your own, I'll write undercoverage, but you should also probably write like maybe the Y. Undercoverage. Okay, survey result says 90% of the U.S. adults rarely use their cell phone. Researchers called the method of survey, they called randomly selected homes and inquired as to how often they use the cell phone. So based off of their results, they said 90% of the U.S. rarely use a cell phone. So what type of bias would that be? That would also be undercoverage. And why would that be undercoverage is because many people who rely on cell phones surveys do not have home phones and would have been excluded from the survey. So in other words, like, I don't have a home phone. So if I would not be asked this question. Like, this is probably probably a small group nowadays of people that have home phones still and landlines. Okay, survey results says 2 out of 3 dentists recommend Tooth Lovers toothpaste. The method of survey, they polled 15 local dentists and asked them which toothpaste they would recommend to their patients. This would be considered misleading. I forgot to read the directions here. So what type of bias? This would be considered misleading because the results generalize that all dentists prefer this, but there's a strong chance that local dentists are not representative of all dentists. So this is misleading. You take 15 local dentists and ask them, and then you make this claim: 2 out of 3 dentists recommend this. That's not very accurate. So that's what we have today over bias and whatever or not, and then we'll talk about some different types of statistical studies tomorrow.